When we talk about the sizes of atoms or ions, we are referring to the radius. And again, we're going to assume that an atom or an ion has a spherical shape. So that's going to be the distance between the nucleus and the outer edge of the atom or the ion. And that can get a little fuzzy because the outer edge of an atom depends on where electrons are, and that can really vary between compounds. So there are several different ways that we use to determine radius. We have the atomic radius, which we get when we have two identical atoms that are covalently bonded. And so these are going to be nonmetals. We have a metallic radius that we use for determining the radius of metal atoms. And then we have an ionic radius that allows us to figure out the radius of ions. And so we look at this next graphic and it shows us sort of how we can figure this out. The nucleus is indicated by this black dot in the middle of the sphere. This is this is really too big for a nucleus. If a nucleus was this size, the nearest electron would be on the other side of this building. So it's just showing you where that nucleus is, which we can actually find pretty accurately because it's so dense. And when we have two atoms together, we are able to measure the distance between the two nuclei, if these two atoms are bonded, and we divide that by half, and that becomes the radius of the atom. And this radius actually varies according to what atoms are being bonded. So this is the radius when chlorine is bonded to chlorine. If chlorine is bonded to iodine or hydrogen or fluorine, then this radius changes. So we often have an average radius that we use. And then here would be the metallic radius of sodium. Sodium is a metal. Most elements are metal, and most metals exist in the solid state. And so it's easy to measure from nucleus to nucleus, and again we take half of that distance and we take that to be the radius of a sodium atom. Now ions are different. Ions have either lost an electron to form a cation, and the cations are always smaller than the atom, or they've gained an electron, and the anions are always larger than the atom because they have an extra electron. So we find the sodium, we kind of estimate the distance between these based on the distance between the nuclei and where the outer edges of that ion is going to be, and it can be a little bit fuzzy. So if we think about atomic radii and the size of atoms, they increase as we go down a family. And of course that makes sense. As we go down a family, we're getting more electrons. That makes sense. However, if we go from left to right, the size decreases. And that really doesn't make sense because lithium only has 3 electrons and neon has 10, and it looks like neon is less than half the size of lithium. Why is it? Well, it has to do with something known as the effective nuclear charge. If we look at lithium, it has an atomic number of 3, which means its nuclear charge is +3. Neon, on the other hand, has a nuclear charge of +10. As we look at these main group elements in the second period, the n equals 2 s subshell and the n equals 2 p subshell are being filled. We're in the same energy level. Because neon has a much higher nuclear charge, it's able to pull electrons in much closer to it. So the 1s electrons are far closer to the neon atom than they are in the lithium. And then the 2s electrons are far closer as well. So because of the higher nuclear charge, neon is actually smaller than lithium, even though it has 7 more electrons. Now as we go down a family, the nuclear charge is also increasing, but what we're doing is we're adding electrons to a new energy level or a new shell, and by definition it's further away from the nucleus. So as we go down a family, Our size always increases because we are adding electrons to a new shell, and as we go across a family in the main group, we are feeling the same energy level, but the nuclear charge is increasing. So the size as we go from left to right decreases. Now let's take a look at ions. If we're looking at cations, the cation is always smaller than the atom because we've lost electrons. If we look at anions, the anions are always larger than the atom because we've gained electrons. And as we go down a family, our cations become larger or our anions become larger as we go down. So for a given family, the ions are going to increase in size as we go down. Now let's take a look at this isoelectronic series: sodium plus, magnesium plus, aluminum plus, oxide and fluoride. All of these have 10 electrons. And you can see it from this graphic, and you can also remember it. The higher the more negative the charge for an isoelectronic series, the larger the species is going to be. And the more positive, the smaller. So aluminum plus 3, magnesium plus 2, sodium plus 1, fluoride minus 1, and oxide minus 2 all have 10 electrons. The largest is the one with the most negative charge, that's oxide, and the smallest is the one with the most positive charge. So those are the trends for ion size that you should remember. Going down a family, the ions become larger, and for an isoelectronic series, the most positive is the smallest, whereas the most negative is the largest.